And let me once again officially welcome everybody to today's online event, Using Excel NetMap for Social Network Analysis. Today's event is sponsored by the Harvard Kennedy School's Program on Networked Governance and the Government Innovators Network. And I'd like to pass things off to David Lazer, who is the Director of the Program on Networked Governance at the Harvard Kennedy School, for some introductory remarks. David.
Thank you, James. And I want to begin by thanking Jim Cooney, who's providing expert hosting for this event, as well as to the Ash Institute, who's providing the infrastructure. This is wonderfully generous of both Jim and the Ash Institute to be helpful. Let me just begin with a few remarks, and then I'll pass it on to the main event. The idea of this event, I guess, is to practice what we preach, which is to use technology to enable learning and to create community. I think universities produce so much information and knowledge in few places, more so than Harvard. But so much of that stays within the room, and at Harvard, at least, there's often little diffusion even outside of the room, which I think is inconsistent with our broader mission. So I'm using the colloquium series I've been running, the Cambridge Colloquium on Complexity and Social Networks, which I've been running for 8 years, as an experiment of sorts of putting some seminars online and see whether this opens the door for access to people around the country and around the world, I hope. So before beginning things, I'd like to just get a sense of who is here. So I just have a couple of quick questions. Obviously, people can see on the list in the bottom left who is here. But generally, I'm curious. My first question is, how many people are at each terminal? If we can put that up, Jim. Oh, there we go. I'm just curious if there are cases of more than one. Sometimes I've done these events, but it looks like let's see. Just going to wait a few more seconds. So it looks like most of you are just eating sandwiches by yourself in watching this event. I was just curious. We'll just wait a few more seconds here. All right, and I'm also curious about the geographic dispersion of folks. So if people could just check where they are sitting right now. Okay, interesting. All right, so we are hitting disproportionately the East Coast, but we are actually getting at least almost 10% of folks of our audience, around 10%. That just hit 10% from outside the U.S., which is good. All right, so I just wanted to get a sense of where people were coming from, and let me also mention at the very end. Okay, let's see. We have a few more here. Okay, in terms of non-U.S., Europe, and some non-U.S. U.S. North America. So at the very end of this event, there's going to be an open field question for you to provide feedback on this format, whether this kind of event was useful. Please do take a couple minutes to write in a few comments, and we'll take this as input as to whether and how to do this again. You should also feel free to email me privately. And other than that, let me just move on to the main event. I'm very pleased to have Marc Smith, and Marc is a good sport to be a guinea pig for this event. Marc is the soon-to-be chief social scientist at Telligent, and was recently of Microsoft Research, specializing in the social organization of online communities and computer-mediated interaction. I'd say, if I were to use a phrase to describe Marc and his work, would be that he's one of the first computational sociologists in the world, which I mean as a compliment. Generally, his work has centered around collecting online data, let's say from Usenet groups and the like, to understand computer-mediated collective action. And he's been good enough to create various tools for the rest of us to use along the way, which I think has been a wonderful contribution to the research community, including the NetScan engine that allows researchers studying Usenet groups to get extract a variety of data from those Usenet groups. And of course, what we're talking about today is an effort that he's led in creating this add-in for Excel.NetMap. And well, you'll know all about that by the end of the hour. So in any case, with that, I'm going to pass the baton on to Marc. And again, thank you very much, Marc, for being willing to do this.
Why, thank you, David. I'd like to thank everybody for coming, and certainly I very much appreciate the invitation and the opportunity to address you all. Special thanks to Jim. It couldn't have been done without you. So I'd like to just note also that I've recently changed my affiliation, and I am now with the Telligent Corporation. This is work that was done largely while I was at Microsoft Research. And if you can all see the title slide now, I'd like to just mention the names of the many people who have contributed so much to this project. First off, my intern this summer, Vladimir Barash from Cornell, our very capable developer who has built all of Excel.NetMap and many of the other tools that we've used, and that would be Tony Capone. In the time now that I've departed from Microsoft, the leadership of .NetMap is being passed internally to Dr. Natasha Milish-Frayling, now at Microsoft Research in Cambridge, and her colleague also in the Cambridge lab, Eduarda Mendez-Rodriguez. My colleagues also include Eric Gleave at the University of Washington, Adam Perrer, formerly at the University of Maryland, and Professor Ben Schneiderman, also at the University of Maryland. And I believe I have omitted, sadly, Cody Dunn, a student of Ben Schneiderman, who has recently joined the project to assist us. So let's see. First off, I'm a sociologist, and my interest is, as David mentioned, the computer-mediated collective action phenomena. This is the realization and the recognition that networks are not about accessing computational resources. They are about providing the infrastructure for human association, and with human association comes the capacity for collective action. And much of what is interesting on the Internet is the product of collective action. Things like wikis and blogs, news groups, discussion forums, web boards, link stores, photo archives. All of these artifacts are collectively authored, and they have turned out to be one of the greatest sources of value on the Internet. The amazing thing about them all is that they are built by many people. Not necessarily each person making an equal amount of contribution, but large groups of people often spread around the planet, often with very little coordination other than the infrastructure itself. So the other common theme to all of these collective goods and the nature of these interaction tools is that they author directed graphs. Directed graphs are the data structure in social networks and other forms of network data structures. Directed graphs are very complex data structures that involve relationships between entities. And it is useful to explore these directed graphs. They are in some ways the common data structure among all of these otherwise disparate forms of social media on the internet. A wiki is not a blog is not a news group is not a chat room, and yet all of them author through the interactions of people with other people on these through these tools. Each of them authors a form of directed graph. The challenge, I think, has been, and I'm going to attempt to advance my slide here, let's see, is that network tools are often designed for a very expert population. There are many fine tools out there that provide extensive support for network analysis, and many of them deserve mention. PIAC amongst them, UCINet, NetDraw, the Jung Project, Guess, Prefuse. All of these tools are very capable tools for providing network analysis. So one question might be, why do we need another one? Well, in part, the answer is that those tools are very capable tools, and somewhat like the flight deck of a 747, can be quite daunting to the new user. And in many cases, I would even argue about 80% of the cases, what people want out of network analysis is much simpler than what is being provided by these tools. There is a steep learning curve. And so in an effort to bring network analysis to a larger population and to simplify the process of doing network analysis, we've been exploring a way of enhancing Excel, certainly one of the most common and widely available data analysis tools on earth, to enhance Excel in such a way that it can support at least many of the basic operations of network visualization and analysis. And so we have been looking at Excel as a platform for supporting our own efforts in doing research out on social networks. So let's see if I can advance here. I am finding that to be a challenge. Let's see. Jim, do I have to click in a particular? There we go. Okay. So we've been engaging in a project where we're interested in the social network science of science. We're interested in studying how scientific discussion on the Internet takes place. In order to do that, we found ourselves in need of a tool. And so simultaneously, in parallel, we are developing .NetMap, the Excel.NetMap tool, to help us manage this data that we are extracting from places like the sci.meteorology discussion in Usenet, or email lists related to climate change or high-energy particle physics. We have assembled a remarkably divergent team of complementary skills. We have a sociologist, a user experience and information visualization specialist, computer scientist, and of course a very talented software developer. The team comes together to not only design the tool, but to design it in an iterative process in which our sociologist is actively making use of the tool. And as that sociologist bangs up against user issues, obstacles, limitations, we take that as input to help us drive the development of the tool. And I certainly welcome all of you to add that input to our design process, and I'll point you to our website at www.codeplex, that's C-O-D-E-P-L-E-X, codeplex.com/netmap. And you'll find there a discussions tab, and we would be very eager to hear from you, especially after you try working with NetMap, and if you find what's good or bad with it, we'd like to hear it. One of the things about network analysis that's very attractive, I find, is that these images can be very compelling. Here on slide 5, we are looking at the cover of a Scientific American issue from 1991. I actually picked this one up on the newsstand way back when, dating me somewhat. And you'll note that this was essentially the issue when Scientific American discovered the Internet. And while there are many very interesting articles in this, I'll note Al Gore wrote an article there declaring the Internet to be a very valuable resource. What really caught my attention was this cover image. And this cover image, in many ways, captured my imagination because I, at the time, was trying to study email lists and discussions on what were soon to be called virtual communities. At the time, I was studying the WELL, the Whole Earth Electronic Link, one of the earliest online communities housed here in California in Sausalito. The WELL was one of the first conferencing systems using the Caucus software to allow people to reply to messages posted by other people. And even then, I recognized that the data structure underlying this kind of social interaction was a directed graph, and that it would be helpful to be able to explore and visualize directed graphs, perhaps in a way that looks like this. Now, in actual fact, this may have led me on a 16-year detour, in that directed graphs are often very difficult to interpret. Here, an image from Payak is the naive or just basic way that a directed graph may appear when you attempt to visualize it. Rather than the ties that bind, in some ways these may be the ties that blind, obscuring the very phenomena that we are seeking to identify. Many cases there are just too many dots, too many edges to actually see any structure. And the challenge is often that the tools are quite complex for whittling away this data to find at the core some data structure or phenomena that is of interest. Other tools like Jung also have these kinds of qualities and add other burdens, especially to the non-technical scientists, those who are engaged in investigations that do not necessarily bring coding skills to the table. Many sociologists I know from personal experience have the challenge of managing large amounts of data without training in the computational sciences. They are not programmers. So things like Jung certainly can do almost anything in the hands of a talented software developer. The challenge is that the very people with the data are not the people with that kind of skill set. And so we are looking to explore ways of getting tools for directed graph analysis into the hands of people who lack these programmatic skills, and we seek to improve the ways that these graphs will appear. Now, it could very well be that these directed graphs are appealing to us without regard to the value they deliver. In other words, we look at these images, for example, of connections of the Internet across the United States of America, and the way that these lines interfere with one another perhaps is just aesthetically pleasing, even if it does not deliver any analytic punchline or payoff. It could just be that we've spent a lot of time, I know I did in the 1970s, doing line art or string art. You drive nails into a board and then tie strings to them. This is what we did before there was an internet. But that moire or interference pattern that appears when many lines overlay one another may just be something that is aesthetically attractive but not in fact analytically useful. To address that, we're going to try to find out what happens when much simpler tools for network analysis are available to a much larger population. And so I'll note that even when we use these tools and the tools generate images that are not perfect, they do have value. Here we can see a directed graph that represents the relationships in a Usenet news group. Now, I realize that Usenet is a remarkably old school kind of environment, but it is one that we have collected a great deal of data about. Usenet, for those who are not familiar with it, is one of the oldest discussion systems on the Internet, invented in 1979 and then reinvented in 1982. Usenet is the place where things like rec.pets.cats exists, a news group that contains messages in a threaded data structure, which is to say messages with pointers that point back to their parents, messages with replies. Here, what you're seeing is a set of relationships, each dot representing an author, and each arc, edge, or a line representing the relationship I replied to you. And even in this naive representation, we can see that there are some interesting structures that call our attention to the data and make us wonder, what are those cone-shaped objects? Who are these people who have, well, what turns out to be a very high degree? Many of you are no doubt already familiar with the language of network analysis, but for those who are not, I'll just note that degree is the measure of the number of relationships any entity may have. So degree in this case is, for any given author, how many authors is that author connected to? Well, here in this image, we can see two people who have particularly high degree. They are called out, and I think that you will see them with some circles over them shortly, I hope. These are the people who, yeah, there we are, and one more. They are the people who have the highest degree in the network. And when we first saw that, we thought, well, at the very least, we have a question. Who and what are those entities? And this led us to a deeper understanding of the social organization of online communities in general, and in particular Usenet news groups. And we then went and explored more deeply these kinds of structures, and we found something very useful. We found that, and you can see this here on the next slide, that in news groups there were these entities that were very different from everyone else. If we were to calculate for every node in the network its degree, we would find that there are some outliers, people with very high degree. Now, of course, degree comes in flavors, which is to say that there is in degree and out degree. In degree being the number of replies somebody receives, out degree meaning the number of replies an author gives to others. And here in this image, you can see, I think, two kinds of or classes of people. If we can advance that, I think I'm having a hard time making the builds happen. There we go. So the grayed out lobes, those are clouds of authors who share what in network theory is called structural equivalence, which is to say they have the same kind of pattern of connections to others. And you'll note that each of those dots, and those dots represent authors, each of those dots has an arrow pointing at them, but no pointers coming from them to others. Another thing to note is that none of these dots seem to be connected to each other. The other kind of role in this graph are those two M&M dots. Those dots are what we came to identify as answer people. So the data that you're seeing in this slide is coming from a Usenet news group, the Microsoft.public.windowsxp.server.general news group, a news group that is highly active and is the site in which people can go and ask questions about the Windows XP Server product. What we find in this image is evidence of specialization, evidence of the development of roles. Now, the notion of role is one common to the social sciences. It's the recognition that people do not act in the same way to each other in all cases. In other words, we are different people to different people. A person may be a father and a coworker, a brother and a friend, an employee. All of these things happen perhaps at the same time, often in different contexts though. And these roles can be identified through the pattern of behavior that the person performs, and performs that pattern of behavior with some stability over time. And so what we're seeing in this image is two people who share an interesting quality. They are the people who reply to other people. They are answer people. And they can be defined very quantitatively in network analytic terms by saying that they are people of high degree, which is to say they have many connections, but not just any kind of degree. They are people of high out degree, which is to say that they have connections to many other people that they author by replying to them. They reply to many people. But they are also people of low in degree. They have very few replies coming back to them. This actually turns out to be because the Internet is a relatively impolite place. When given some service or value, the rate at which people say thank you is remarkably low. So what we can see is somebody has come in, many somebodies have come into this environment, and they have posted a question. That will make them appear as a dot. And since that question is not a reply to anyone, they would initially appear as isolates floating around the newsgroup. The answer person, however, replies to this person, creating an arc or an edge or a line that links that node to those other authors, the question people. So we have answer people, people of high out degree and low in degree, and that is a pretty good definition of an answer person. It's a good filter for finding answer people, but it's somewhat incomplete in that what we can also say is that the people that answer people connect to themselves have low in and out degree. So the complete definition of an answer person might be a person of high out degree who connects and low in degree who connects to people of both low in and out degree. And so what we are moving towards through this process of discovery of structures within social media is that there are network motifs, patterns that are recurrent across many of these repositories that highlight roles some people play. And it's an important role. If these M&M kind of people here on this slide were to disappear, what we would see is a cloud of people who, having asked a question, got no answer. And it's worth noting that these question people themselves never reply to one another. And so the clueless need the clueful. But contrary to that, the clueful also need the clueless. If it were not for these question people coming into the environment asking questions, these two answer people would have very little to do. So we built this image actually with Jung, and we found that making manipulations and changes to these images was always a challenge. And so we started a project in which we were building a rich client to provide better tools to gain access to this. And you can see here in the next slide another image that shows the answer people. There you can see two highlighted answer people. And you can actually see that there are several others, but these are the top answer people, showing that this is a pattern that is recurrent across many different social media sites. This, I believe, is a news group devoted to the discussion of different server product. Over on the right-hand side of that screen, though, and this is an image from a much earlier version of NetMap. We actually had a different name for it back then. That image is from the Chung project, the C# Universal Network Graph project. We subsequently changed the name to .NetMap. But over on the right-hand side of that screen, you see that list of names, and actually if you were to scroll through that, you'd see that there was a bunch of metadata over there about each of the authors. As we began to develop this tool, that pane became richer and richer, and it started to take on a lot of similarity to Excel. And at that point, we decided to stop cold and think more deeply about what we were doing. And we realized that we were in no position to start building Excel. Excel is a decades-old product with probably billions of dollars of investment and perhaps one of the most complex software products ever used widely. And we decided to back away from that and recognize that what we should do is actually lean on Excel to leverage the rich functionality of the Excel product and bring that into our project. In doing so, we find ourselves really liberated to focus on just the network attributes of our tool development rather than trying to rebuild what has already been built. So I'm going to move forward and just show you how that tool has then delivered some sociological findings. And then I'm going to turn around and look at .NetMap in some detail and show you some of the features of that tool. And at that point, I'd even like to encourage folks who are listening perhaps to send me a data set. I have some data, and I will demo with that data. But if you have a relatively modest-sized data set, so as to make it easy to send and receive via email, one of the things I'll do at the end of this talk is to try to grab somebody's data set and actually run it through .NetMap and show you how we can go from an edge list to a network diagram and then filter that diagram relatively quickly. So if you have an edge list out there, and basically you can either send it to me in Excel or a comma-separated value file where it would be entity name, and if you've got it, tie strength. We'll see if we can actually run that through .NetMap here in the context of this talk. So the slide you're now looking at should say distinguishing attributes, and what I want to show you is that answer people are not the only role present in these discussion environments, and that network properties, social network properties, are very effective at illustrating the differences between these roles and add value to our understanding of these social media environments by highlighting a kind of ecology of social roles, a recognition that it takes more than one kind of author to make a community function productively, and that different kinds of ecologies exist in social media spaces. In other words, there are genres of social media. Some, like those that have answer people, are of the genre Q&A, question and answer, places where a kind of transactional, factual exchange is taking place, a place where you ask a question and get an answer. This is not only...
Jim Cooney, I'm sorry to interrupt you, but we're definitely getting some interest from people who would like to send send their data sets. Some people are asking your email address, and then somebody is asking about what format the data must be in. So maybe we could just go over that again, and I can post this information once you announce it verbally. I'll post it in the question and answer box in the bottom right side of the screen so people can view it there if they don't have a chance to write it down.
Great, and thanks for the interest, folks. So first off, you can send it to me at my email address. I'll just say it fast once and then I'll spell it out. mark.smith.email@gmail.com. That's Mark with a C, mark.smith.email@gmail.com. And I should note that that email address is probably temporary and that you can find me later at mark.smith@telligent.com. But that email address is not working yet. What kind of format should you send me? If you have a spreadsheet with 3 columns, and that would be some unique identifier, another unique identifier, and a tie strength, that will do. You could even give me less, and that would be just columns A and B. And in columns A and B, I just want the name of the first entity, the name of the second entity. If you have additional data, like the tie strength, put that in column 3. If you have other metadata about the edge or the vertex, which is to say maybe you know the age of the author, or you know the market capitalization of the company, and so on, those can be in additional columns. And one of the great features of NetMap is that it allows you to use these extended metadata attributes to drive the visualization. And I'll make that a little bit more concrete as we go forward. But the example would be, let's just say that you have the income of an entity in your graph. We could make that income map to the color or the size of the node in the graph, and I'll show you how to do that. So again, the data structure can be either in Excel, or it can be simply in a text file with commas separating the values, and it will come in the form of 3 columns, or even 2. And these are just the name of the first entity, the name of the second entity, and then whatever extended metadata you happen to have about them.
And Mark, I have one more question from Jennifer is asking, could I send an adjacency matrix? I don't know how to convert my adjacency matrix to the edge list that you're...
Yeah, actually, you have identified a feature that is on the pending work item list. We do not at the moment convert adjacency matrices back into edge lists. That is a work item that we're considering, but at the moment we do not have that functionality. So I couldn't really do that on the fly right now. But if you do have an edge list, I can process that very quickly.
Great. I think we covered everything, and Mark's email address is now located in the question and answer box in case you didn't get a chance to write it down fully. So hopefully you'll be receiving some email attachments. Please continue.
Okay, thank you. So I'm going to continue with the sort of sociological payoff of this kind of analysis for social media, and then we'll move to how to actually do some of this in Excel.NetMap. So you see on the screen this sort of starburst pattern. This is the distinctive pattern of an answer person, a person of high degree. They're connected to many people. The people they're connected to are not, for the most part, connected to one another. Therefore, there are people of high degree who are connected to people of low degree. And you'll notice that in some cases we violated that. There are a few crosswise connections there. But there is this notion in social network theory of a triangle census, or a clustering coefficient, which is to say how connected are the people I'm connected to one another. And what you can see is that it's a relatively low ratio, that the people here are not connected much to each other. Let me move that forward, though. And let's see, and Jim, maybe you can help me there, move to the second part. Thank you. There you can see a different role, the role of the reply magnet. And I should call out the work of Professor Itai Himmelbräum at the University of Georgia in Athens, who is working on a project with me to identify the people in political discussions who are capable of catalyzing conversation, which is to say that these are the people who, when they generate a new thread, they start a conversation, that conversation actually takes off. And we defined these discussion catalysts, or reply magnets, as the people who were able to get the lion's share of all people who replied to reply to them, and of all the replies, the lion's share came to them. And we found people who were able to get a third of all replies and repliers to reply to them. Interestingly, the reply magnet is in some ways the inverse of the answer person, which is to say that they are people of low out degree. That is to say, they do not reply to other people. Interestingly, we found that the people who could start threads effectively were themselves relatively rarely involved in the conversations they started. They started the fire, they did not fan the flames. So what you see is an image of a reply magnet, somebody who has many arrows pointing into them and very few arrows pointing out from them. And it's worth noting that the reply magnet is linked to people who are linked to one another, at least more so than the answer person. So they are connected to people of relatively high in and out degree by comparison. So let me move you forward to the next image, which shows the alternative to the reply magnet, which is to say the discussion person. The discussion person is the person who actually engages in that conversation that the reply magnet starts. They are the people who are having the conversations, and we can also identify them in this graph theoretic manner, that we can actually say, oh, well, these are the people who have both high in and out degree, and they are connected to people of high in and out degree. So on the next slide, we can see that there are clear and consistent signatures of each of these roles. And here you are seeing a particular role, the answer person, in 3 different images. The middle image you are now familiar with, the directed graph. And in this case, this is known as an egocentric network graph. It's just taking that one entity out of the network and looking at the 1.5 degree connections between those people. Whoop, I think we've gone too far. Hang on, let's go back a slide. Here you can see that this is an answer person because the people they connect to are relatively unconnected to one another. In the next image, in the histogram right next to that directed graph, you see that there's this pretty big drop-off. That histogram is the measure of how many connections do the people I connect to have. And the fact that there is a big bar in that first spot, which is the 0 spot, that says that this person, the ego here, is heavily connected to people who are not connected at all, and very lightly connected. You can see over at the other end here, at the far end, there are only a few people that this person connects to who are themselves highly connected. The image that is the first of these 3 images kind of looks like a beaded curtain. It kind of dangles downward. We call that an author line image. This was developed with Fernanda Villegas, now at IBM Research, and can be a more detailed description can be found in a paper called Picturing Usenet, which was published at the Hicks conference. That's H-I-C-S-S, Hicks. That paper describes a way of visualizing the pattern of behavior of an author such that you can see the way they initiate and reply over time. And this beaded curtain kind of image shows that this is a person who consistently replies to others while staying out of large conversations. So these multiple facets of behavior allow us to zero in on and identify the patterns of connection between people and use those patterns as an identifier for the roles they play. And here on the next slide, you can see that there are different roles people are playing, and this can be seen in their ego nets at the 1 and 2 degree level, really 1 and 1.5 degree level. And then the histogram, and I love this histogram essentially is egos, alters, out degrees. I just like that phrase. If you say that several times, people will give you grant money. Egos, alters, out degrees. That's the key person's friends or connections and the number of connections they have. Egos, alters, out degrees. And it's a way of getting at the various kinds of roles people are engaged in. This is also documented in a paper also published in Hicks, co-authored with several people, including Danielle Fisher and Eric Gleave, which was entitled You Are Who You Talk To. So you can see, I hope by now, that network analysis is a useful approach for the understanding of many phenomena in general, and certainly social media phenomena in particular. And we'll now kind of turn to the recognition that the tools for doing this are somewhat limited. While at Microsoft Research, we engaged in an exhaustive study of Excel, and we found that no network chart exists in Excel. And in fact, on further research, we confirmed no network charts in Excel. There are so many charts in Excel. It took us a while to convince ourselves there are no network charts in Excel. Every other kind you can imagine, but no directed graphs. So we set out to actually build our own. So if you were to download .NetMap, what you'll first see is a series of workbooks, each which is devoted to a different element or facet of your own graph. So there is an edges worksheet, and it simply contains, at the very minimum, column A and column B, which is to say Bob is to Alice or Sally is to Jane. There is a relationship between A and B. In the vertices worksheet, we simply populate that with the unique list of every node, each vertex in the graph. And it's on the vertices worksheet that you would be able to place metadata about each node. Maybe you know their height, or their weight, or their income, or their zip code. You may know many elements about the entities in your data set. That would go on the vertices worksheet. If you have metadata about the nature of the edge or the relationship, that would go on the edges worksheet. The images worksheet simply is a place to store pointers to a image file, a JPEG, a PNG, or a bitmap that represents the node. We wanted to do this for the kind of thing that you might do with, let's say, an analysis of Facebook, where you wanted to actually put the picture of the person in place of the node. We do give you a great deal of control over what the node should look like. We can make it a dot or a circle, a diamond or a square. It can be of different sizes. It can be of different colors. It can even be of different translucency or opacity. But we understood that there will be conditions in which people want to actually see an image. At the moment, one of the constraints, and I should note that .NetMap is still relatively young and is not feature complete, those images must be on the local file system, and on the images worksheet you'll simply put the path to that, give it a code or an identifier, and wherever you put that identifier over in the vertices worksheet, we'll replace the dot with that image. Clusters and cluster vertices are two worksheets devoted to the features related to clustering nodes. In other words, you might say, half my nodes are students, half my nodes are teachers, and I want to put some nodes in the student bucket and some in the teacher bucket. Using the clusters and the cluster vertices worksheets, that's something that you could do. We do have some very rudimentary clustering features that will do that automatically for you, but we really have only implemented a single clustering mechanism. We recognize that there are many out there, and I will note that whatever we have not yet implemented, you may be able to implement for yourself because all of the code for .NetMap is available at CodePlex. And I will also note that we are under an MPL license, which means that you may make derivative works of .NetMap in any way that you like. The final worksheet is overall metrics, and that's where we put summary data about the size and degree of your global graph. So some metadata about your graph goes there. On the next sheet, you'll see the edges worksheet, and you'll also get a view of our menu bar. Up on the ribbon, when you open a .NetMap template file, you'll see the .NetMap menu item up in the ribbon. There is a user experience bump, I would say, in our workflow, and that is this. The .NetMap features are invisible and inaccessible in Excel if you simply open up Excel. We require that you open up the .NetMap template in order to expose those features. And there are some design reasons why we do that, largely because the worksheets are very highly structured. There are named regions, and for the end user to actually begin to author all those named regions, I think, is probably unlikely to be done accurately. So what you need to do is go and click on that circle button, that new button they've added to Excel, the button that is up in the upper left-hand corner of Excel, and select New, and you will be given the option to create a new .NetMap template. If you select that, you will then note that the .NetMap menu item is then visible. And you can then paste your data, and you can see where it says Vertex 1, Vertex 2. If you simply pasted your data right there, it would work just fine. I'd like to walk through just a quick overview of those menu items, and I'll just give you a quick description of each, and then we'll move to what you can do with those features. Up in the upper corner, we have graph type. At the moment, it is showing the graph type as directed. Another alternative is undirected. In an undirected graph, we remove all arrowheads, so there is no directionality of a tie, and certain measurements, network metrics, are calculated differently, or in some cases not at all, if you have an undirected graph. Below that is Show Hide Graph Pane. By clicking that, you will actually make the graph visualization appear. Below that is Autofill Columns. One of the most powerful features of NetMap is to simply say in this dialog box, here's how I want you to map metadata to display attributes. So an example of that will be shown later, but I'll just say now, you could say the node or vertex radius, the size of the bubble, is equal to some metric in the spreadsheet. Simply by saying map that metric to this attribute, .NetMap will forevermore make that attribute the guide or the determinant factor for the size of the node. We have import tools. We can allow you to import from other worksheets. It remains a fairly crude tool in that you must have in the other spreadsheet the worksheet that the data you want to be in the dominant position. You have to have that be the active worksheet, at which point you will be able to import with a button click. Moving over, we do have a help item there, but we also have a merge over in the edges menu item, merge duplicate edges. In other words, we're beginning to provide some tools for cleaning your edge list. When you merge duplicate edges, if you have in your edge list A is to B, and that A-B relationship appears 20 times, we will remove 19 of them and then replace it in one of those rows with A is to B, and then we will add the number 20 in the third column, into the tie strength column. Moving over to the vertices, there are copy vertex names. That's just to generate a unique list of all the nodes. Customize vertex menus allows you to add right-click behaviors to every node. So that would mean that you could say, for example, right-click a node and email that person, or right-click a node and see the URL of their home page, and thus click to it. This just allows the .NetMap canvas to become a more living thing, an actual interface to other data rather than the terminus of data. Moving over another one, we have Calculate Graph Metrics. I'll go into that in some greater detail. We have only implemented a handful, about 5 different kinds of network measures. We're very aware that there are many more, but we think that we've picked the 5 that are the 80% case. And we are eager to hear from you about the metrics that we have omitted that you feel are high priority. We do not believe that the future of .NetMap is to overtake libraries like those found in RSNA, or for that matter in tools like PIAC, that have perhaps the most exhaustive and complete sets of network measures available. However, we do believe that we can deliver about 80% of the user case scenarios with a handful of metrics, and hopefully we are right about that. If we're not, please let us know. And then finally over there, you'll see below that, Calculate Graph Metrics. Below that there is Create Subgraph Images. This is a way of creating ego nets in an automated way. And then Create Clusters and Show Clusters, 2 features that we've just implemented that allow you to gather some nodes together. I will note that clustering is not yet a feature of the layout algorithm, but that is a work item for us. So here on the next page, you'll see the vertices worksheet. That's where you see all of the extended attributes of each vertex or node or entity in your graph. And you'll see that we have attributes like the color, the shape, the size, and the form of the radius, the opacity. Here in column F, you'll see image ID. That is where you would put a number that points to a picture, and we would use that to decide whether or not we would show a dot or a circle or a photo in place of the node. Primary label fill color, secondary label, these are all about putting some text label on your nodes. Primary label replaces the node itself with the text. Secondary label adds a little superscript next to each node. Tooltip is another kind of label. It allows you to declutter your graph by making the labels hide until a mouse over. The column What to show determines which of all of those prior kinds of labels and images we should prioritize, so that way you could have an image ID and be able to suppress it simply by going to the what to show and saying you want it to actually show the primary label, not the image ID. Then there's the visibility column, slightly cut off, but perhaps the most powerful column there is the visibility column, and I'll talk to you about that in just a little bit. I see that there is a question from the floor, and I think the question is, do we require Office 2007? And I have to say that yes, the answer is we require Office 2007. It is not working, or it will not work on Office 2003, and despite the numbering, it will not work on Office 2008, which is the version that runs on the Macintosh. For all Macintosh users, I apologize. In essence, you will need to run some kind of VMware or virtual machine and run Office 2007 in order to access .NetMap. We have made many dependencies on things like .NET, the VSTO, the Visual Studio Tools for Office, and many of the Microsoft technologies have made this possible. We probably couldn't have done it without those technologies, but it does put us in a dependency condition. For the next question that I will anticipate, no, you don't need Vista, but you will need at least XP. So a recent version of XP or Vista and Office 2007 are requirements for this tool. So here on the next slide, I can show you the kinds of images that you can generate with Excel.NetMap. That's kind of a pretty picture. Excel.NetMap allows you to make nodes translucent. We can lay them out using multiple layout formats. One might be the Fruchterman-Reingold force-directed layout. Another might be simply to put things in a circle or in a grid. We have a handful of layouts. Layouts like clustering and like metrics are an area where there's a lot more work to do. We do expect to enhance our layout options in the coming work items, and I'll tell you a little bit about the future of our work items in a few seconds. The next image illustrates the primary label layout. Here we're using labels instead of nodes, so instead of a circle or a dot or a triangle, we're using the actual names of the vertices as their node representation. Here these are the collaboration relationships in a research group at Cornell. In the next image you can see the circle layout. This is a layout representing the flow of information or news articles from one nation state to another. It's worth noting that Britain, for example, exports and imports news from many more nations than the United States, which is mostly an exporter of news rather than an importer of news. In the next image, you're seeing a naive representation of my Facebook graph. Perhaps some of you are my friends. If not, I'd be delighted to be your friends. Here on the next slide, we've done a little bit more with the layout where you can actually see some clusters starting to emerge. Those two clusters in my Facebook graph actually represent everyone I know at Microsoft and then everybody I know who is not at Microsoft. You can see those clusters a little bit more clearly because we've pulled all of the heavy hitters, the people with the highest degree, out to the edges of the screen. One of the nice features of .NetMap is that it allows you to move nodes manually simply by clicking and dragging them around. And if you want then to lock them to the canvas, right-click them and you can access a dialog box that allows you to lock those nodes to the canvas, making them immobile even when you apply other network layouts to the remaining nodes. What we're finding is that using multiple layouts, taking some nodes and applying them, let's say, in a circle layout, and then locking them, and then letting the remaining nodes float under a Fruchterman-Reingold layout, can be one of the best ways to get meaning out of your graphs. Graphs remain very challenging diagrams to get meaning from, but the application of multiple layouts is a particularly powerful way of getting more meaning and comprehensibility from your graph. The next slide simply shows the circle layout. Again, not the most comprehensible graph, but we're working on that. It is a way of getting certain kinds of relationships to be more visible. Certainly the big nodes are a real standout here, and you can see how they are related to other people in the circle. The next image, create subgraph images, is a dialog box that you can access through the menu bar. And this dialog allows you to generate egocentric networks for every node in your diagram, in your graph. And we'll do more than one thing with those ego nets. One thing that we will do is generate GIFs or JPEGs and stuff them into a subdirectory for you. And I'll point you to the work. I don't think I have the image in the deck, but it's a very compelling image. The work of Lada Adamish and her co-authors, in particular Eitan Bakshi. There was a paper at the World Wide Web 2008 conference, and I'm sure if you use your favorite fine quality internet search engine product, you can find World Wide Web 2008 Lada, L-A-D-A, Adamish, A-D-A-M-I-C. Lada's work was to analyze relationships in the Yahoo Answers product. And she was able to show that a grid of ego nets could very compellingly show differences in the social organization of different parts of Yahoo Answers. By that I mean some parts of Yahoo Answers were in fact discussion environments, not answer environments. They were places where people simply asked, rather than asking and answering a question, they were places where people engaged in long discussions with one another without regard to the stated goal of the Yahoo Answers product. We saw these, we called them Adamish plots. Lada's very modest. She notes that it was actually her co-author, Eitan Bakshi. We're now calling them Bakshi plots. The concatenation of these subgraph images was a very potent way of showing the differences, the sociological differences in these different tag spaces. On the next slide, you can actually see some of those egocentric networks. When you tell Excel.NetMap to do it in this way, we'll actually drop a thumbnail of the ego net for every vertex in a column next to that vertex, allowing you to see the diversity of roles present in each part of the graph. This really highlights the way that some nodes are different from the others. There you can see in row 122, for example, somebody with an incredibly dense network, quite different from, let's say, somebody over at, well, I think it's 128. I can't quite see it. But some people are in very sparse locations in the graph, whereas others are in very dense locations in the graph. In the next image, you can see the feature I mentioned earlier, the autofill columns feature. And this is a way of mapping particular pieces of metadata to particular display attributes. So you can see that we have, in this example, mapped tie strength to edge color. Tie strength is also mapped to width and opacity. One of the nice things about doing that is that really thick lines become more translucent or transparent, making it easier to see a very dense graph, to get some meaning from it. By fiddling with the settings in this dialog box, this is equivalent, I think, to the idea of a document template in Word. It's a global set of mappings, and once saved, all other Excel.NetMap images will follow this mapping. You can, of course, override that for any particular one. So this is a way of very quickly saying, here's a bunch of mappings between metadata and display attributes. In the next slide, you'll see our Select Graph Metrics. This is a feature that allows you to choose which of the graph metrics you want .NetMap to calculate. You might not want to calculate all of these metrics, particularly with very large graphs. Very large graphs, for example, in calculating betweenness centrality, may impose a performance hit that would make you go out to lunch and maybe even out to dinner before you got your data back. In some cases, though, for relatively modest sized graphs, you might want all of these metrics by selecting all and then saying, okay, when you next run the calculate graph metrics, we will then insert each of these graph metrics into the spreadsheet for you and allow you to use them as display attributes. You can then say, okay, let me use degree or in degree or clustering coefficient to drive the color, the size, or for that matter, the location of each node. One of the latest features, and as a matter of fact, if you have not downloaded .NetMap today, or perhaps you may want to wait until tomorrow, you won't have this feature. This is the latest feature, and we should note that .NetMap changes pretty much every 2 to 3 weeks. You are likely to find a new .NetMap. I believe we have just released version 58, and version 59 is coming, and I'll tell you about what's coming up very shortly. But this is the dynamic filters feature, and it allows you to sift and sort your data from the canvas. These are all features that you can implement in a more manual way by changing the nature of the visibility column. The visibility column is, as I mentioned, a very powerful feature of .NetMap. When visibility is either blank or 1, the edge or the node associated with that column is displayed. If it's 0, it is not displayed. Sounds simple. Well, with the magic of the formula known as if, that becomes a remarkably powerful feature. So an example would be if income is greater than 100,000, then 1, else 0. This immediately filters everything in your graph based on whether or not the income of that node is above a threshold. What we've done with dynamic filters is to bring many of those attributes up to the canvas to allow you to interactively set thresholds. And I'll note that this is a custom control. You see 2 indicators there. There's the low end and the high end, and this allows you to create any range from all to any sub-range within that distribution to be the filter, the threshold for display in the graph. One of our newest features just added this week. I'm not even sure it's on CodePlex at the moment, but it will be certainly by end of week. I'm testing it right now. We'd appreciate your bug reports as well. So I'll just point to some of the next directions. I skipped one feature that is quite powerful, and that is social network data sources. If you look in the NetMap ribbon, you'll see a feature called Analyze Email Networks. And that feature is limited to our Windows users. It depends on the Windows desktop search feature. But it's a way of providing users with a network. If you came to NetMap interested in networks but did not at the moment have a network, we'll provide you with network data that may be very relevant to you. The Analyze Email Networks feature queries your own email and extracts patterns of relationship based on who replies to who within your mail store. These tend to be very ego-centered, which is to say you are the center of your own email store, and you can often see yourself at the center of a hub and spoke network with all of your coworkers arrayed around you. One of the features that we will be delivering in the coming week or two is a number of additional, what we like to call spigots. When you open a spigot, something comes out. When you open a network spigot, we deliver a network. And we are looking at various social media repositories to extract network data. Facebook is an obvious one, but I should actually apologize to the good people at the Facebook Corporation. Apparently the slides I showed you earlier in this deck are a violation of the terms of service of the Facebook Corporation, in which you are not allowed to hold on to data about your Facebook information for more than 24 hours. I hope no one will mention this to anybody at Facebook. So we will probably not provide a Facebook plugin for .NetMap, but other social media repositories like Flickr, Delicious, Twitter, all provide network data that could be relevant to our users, and we'll provide those features in the coming weeks. Other features that are coming, better layout controls, better clustering, where we actually use the clusters to govern the layout. So everybody in the student cluster would be on one side of the screen, everybody in the teacher cluster would be on the other side of the screen. We will also be making a big push in the coming weeks to update the graphics layer. For the technical people out there, we are a GDI plus graphics display. We will be scrapping the GDI plus layer and replacing it with WPF. That's the Windows Presentation Framework. We will do that in part to realize a different feature, which is zooming and scaling the graph, being able to zoom into detail and making the graph much larger than the size of the screen. Those are features that we do not yet have. They will come at relatively low cost when we move to WPF. We have actually already implemented right-click behaviors, so some of these things are already being overtaken by our developer, who's remarkably productive. So let me just show you an image of a related project. This is Social Action. It is the dissertation work of Adam Perrer, now Dr. Adam Perrer. Dr. Perrer is now a researcher at IBM Research in Haifa. Before he took up that role, he was a consultant to the .NetMap project. And his consultancy helped us make use of some of the insights he gained in his dissertation work. That work, guided by Dr. Ben Schneiderman, was to build a application for the exploration of graphs. And here you can see the Social Action tool, which is also available for download. The key feature here is these convex hulls, these ways of grouping sets of nodes together. We seek to add this kind of a feature for the exploration of graphs in our tool as well. So with that, what I'm going to do is actually go over and share the existing .NetMap chart I have, and I'd love to quickly walk you through that, and we'll see if I can show you some of these features in operation. I'm not sure if that's going to work, but we'll see. There we go.
While you're pulling that up, there are a few questions posted, and I thought we would take a moment to run through.
Sure.
I'll just read some of them to you. Let's see. One question is regarding downloading a copy of the slides. I'll just answer that myself, which is we'll put it up on the NetGov website. So that's www.hks.harvard.edu/netgov, and we'll put it up. Put them up there, as well as a link to the recording of this presentation. There are a few technical questions. One question here is, do you need .NET 3.5 SP1? Do you know what that is, Mark?
Yes, I think you'll want to be a fully topped off Windows platform. I think we are a .NET 3.5 dependency. There's a dependency on VSTO. But I will note that our install process will clean all of that up for you. You may, if you do not have any of those components, if you do not even have .NET, that is a big download. I think it's over 30 megabytes. So you might want to be connected physically to a network when you do this for the first time. But we will set up all of the dependencies for you. You don't have to do that at all.
Okay. Next question. Do locked nodes invoke forces on unlocked nodes in a layout?
Oh my goodness, that's a really good question. I'm actually going to punt that, and I'm going to refer it to my developer, Tony Capone. I believe they do, and I am not sure. So if that person can send me mail, I will make sure that we get back to them with the correct answer. But my guesstimate is yes, I think they do have a force impact on the others. Now that's only under the Fruchterman-Reingold layout and not under the others.
Got it. Another question, is there an instructional website where these menu items are explained along with the basics of how the program works?
We invite that contribution. No, at codeplex.com/netmap, you will find a discussion board where many of these topics have been discussed. We are working on documentation. We are a very small team, and of course documentation is the castor oil of software development. Nobody is eager to swallow that task, but we are working on adding documentation. There is a paper in draft form that is available, and if you use your favorite high-quality internet search engine product to find it by searching for .netmap, it's on a SkyDrive, skydrive.live.com, and anybody who would like to look at that draft, I'm happy to send it to them. But yes, we are definitely lagging in our documentation effort as we focus mostly on implementation. But that is certainly a work item that we will be prioritizing.
Okay. Next question. Actually, I should be saying people's names as I post these. This one is from Camille Ryan. ORA, another social network analysis tool, recently added an ARC/GIS capacity to their software, meaning relational data can be applied to a geographic map. I assume that NetMap does not do this. Are there plans to incorporate this capability?
This is a very good question. At the moment, we do not directly support the layout of nodes onto a geographic canvas. I will note, however, that like the visibility column in the vertices and edges worksheet, there is a column in the vertices worksheet called X and Y, or two columns, X and Y. Users may enter any values they want there, and they may also make those values calculated values. So conceivably, you could put latitude and longitude values there instead of the layout that, let's say, Fruchterman Reingold would calculate and impose there. If you were to do that, if you were to enter those values, you would most certainly want to apply the locked feature. There's a column with the name locked. If locked contains a 1, then those X and Y values will not be overwritten even if you apply a different layout. So in many cases, .NetMap may not directly support a feature, but can be made to implement that feature because of the power of Excel beneath it. But yes, this is a very real omission and limitation of .NetMap. As I say, there are many other very fine tools out there. It is a direction we are considering, though, but no, not yet today.
Okay, just a few more questions, and then we'll move on. In the autofill, does it only work related to metrics? This is from Laura M. Does it only work related to metrics, or can I use it related to attributes I include, for example, nationality and gender?
Autofill will allow you to include all sorts of other columns. If they are in named columns, they become attributes that you can include. So nationality could very well be a feature. Now, nationality ought to be numeric, though, and so these are all mostly numeric values. So the answer is probably maybe. I hope that was definitive enough.
Okay. Yes. Well, if it's not Laura M, you can email Mark. Let's see. And next question by Rosanna: does this work with Lotus Notes? I assume the data extraction capacity.
No. Well, actually, yes. If Lotus Notes is being indexed by Windows Desktop Search, the answer is yes.
Okay. Excellent. And from David Pope: is there a recommended practical upper limit to the number of nodes because of calculation speed, size of graph, etc.?
Yes, there are. So on the one side, the limit is essentially the same constraint imposed by the newest version of Excel, which I believe is up to 1 million rows, maybe more, and I think it's mostly disk, CPU, and RAM constrained. So that's sort of the physical limit for the graph. The practical limits, as the questioner notes, are quite a bit less. So you really, well, I would say that there are two constraints in addition to the physical resources. One constraint is after a certain threshold, the visualization turns to a pure black. In other words, you've got so many nodes on the screen that you can't see anything. So that's another limit, and you may hit that limit long before you hit storage and RAM and CPU limits. The practical limit, I would say, is somewhere around 5,000 nodes being displayed. And so that's the caveat I want to point out. Using the visibility column, you may have 50,000 or even 500,000 nodes or edges in your diagram. And by setting some set of them to 0, we avoid the computational overhead. So we can digest just the active nodes at the time of rendering. So this allows a little bit more flexibility. But no, if the question is, does .NetMap have any particularly special capacity in terms of very large-scale graph performance? The answer is probably no. We're no better and quite possibly a little bit worse than some of the other graph visualization tools out there. I'll note that very, very large graphs are rarely what you're going to be working on. Chances are you're going to try to subsample your graph in some way, and we've been focusing on, again, the 80% case of, let's say, less than 5,000 nodes, and probably on a screen at any one moment, you're not going to want to see more than, let's say, 1,500. Now, some of you may have very large LCDs out there, in which case you may be able to get a little bit more than I'm mentioning. We have not been making the size performance of NetMap our main focus, though.
Okay, I think that's it for now, and why don't you continue?
Oh, well, thank you, and thank you all for the questions. They're great questions. So I'm just going to run .NetMap through a quick set of operations. What you're looking at is the set of relationships in a news group. Each of these vertices have been given a number. Their actual identity is obscured here. They are email addresses in their raw form. And these addresses have been extracted from the Alberta Politics news group several years back. This is a news group in Usenet, a set of discussions about political activity in the province of Alberta in Canada. And what I will do here first is I'm going to calculate some graph metrics. And so here we can see there are already some metrics. We have in degree, out degree. And one of the nifty things that we can do is simply use the very normal set of tools present in Excel. I'll go to Data, and I'll do a sort. And suddenly I now have my highest degree people, the people with the highest in degree, should be highlighted. That doesn't seem to be right, though. Let's see. So I'll go over here, and I'm going to sort in degree so that the highest in degree people are there, and there we should see some high in degree folks. I will now go over to the NetMap menu, and I'm going to create the subgraphs. And you'll note that we allow you to create subgraphs at any number of steps from ego. And in practice, I'm just going to start with a 1.5 degree, which is showing you that it's the ego, the red dot, and their neighbors, and importantly this pi, the links between neighbors. And I'm just going to insert subgraph thumbnails into the vertices worksheet and not save subgraph images to a folder, but you may do so if you choose, and that's one of the ways that you could then concatenate those images into what I've referred to as a Bakshi plot. Again, you can see a Bakshi plot in the World Wide Web paper from Adamish and Bakshi. So I'm going to hit the Create button. It's going to go off and create those images and then insert them if all is well. I'll then close this, and we should see there the images of each of the nodes now has their own graph related to them. I'm now going to go and attempt to color the graph in some useful way. So we'll go to the Edges worksheet, and we can see that each of these is a relationship. Oh, that's why. I was in the wrong worksheet. If we come back here, let's see, and go to, there we go. If we have in degree, we'll go to data and sort this by degree. And we should now be seeing people, yes, that's what I was hoping to see before. There you can see that when we select a node, we highlight all the incident edges around that node, allowing you to walk through the highest, most connected people in the graph. I'm now going to add some color. So I'll do that by going back to the NetMap menu. I'm going to go to Autofill Columns. And I'm going to say, go ahead and use autofill columns, and let's make edge color the, let's say, degree. So the edge, let's see, we'll make vertex radius. We'll start with this. And we'll say the people with the biggest out degree should be bigger. And we'll say that a vertex should never be less than 2 units and should not be any bigger than 9 units. And we'll say OK, and OK again, and we will now read the workbook, and you can now see that they are sized. Now that's not very attractive though, is it? So we'll come back to autofill columns, and we'll say that opacity should also be about out degree, and that it should actually go opposite, that we should have high opacity when, let's see, no, we should do something like this, I think. We'll say that opacity should be a function of the size of the node. And if I say OK and read the workbook again, we now have a little bit of translucence now. So these nodes are now a little bit more visible because they are translucent when we look at them. Whoops. One feature of Excel, especially when you're working with very little real estate, we've dialed down the size of the screen here to make it universally visible. It's one of the problems with it. Excel likes to grab that screen and dock it. But let's now use some color, and we'll say that the vertex color is going to also be a function of out degree. And I will apply it like this, and we'll, let's say, use blue, and OK. And if I say OK to this, and you can see that this is a reasonably easy way of applying color and shape and opacity to your chart. With a much larger amount of real estate, I might be actually able to see some of the detail here. Let me show you our latest feature, though, and that is over here. I think, where did it go? I want to, yes, the dynamic filters. The latest feature of our tool. And here I can, instead of doing it in batch for a graph as a whole and doing it from the spreadsheet, what I can now do is say, let's filter some edges and let's filter some vertices. Let's see what happens if we say, I want only the vertex that is strongly tied. And we will then see that some vertices have disappeared. I might want to see only the people with high in degree. And again, some things have then disappeared. We can now interactively work with the workbook rather than going back every time to the spreadsheet. So this is a way of limiting, there we go, the view of the chart in some useful ways and in a more interactive way. Newest feature, we're just starting to play with that feature. Let's see, what else could I show you? Of course, you can hide the graph pane, make it appear. We can merge the edges. We could add menus to them. We have already created subgraphs. And we could also calculate clusters. I won't do that at the moment, but I will show you the graph metrics that we currently have. And you can select which ones are calculated. And you'll see that I've skipped between the centrality. One of the things that I'd love for those who are listening to contribute is proposals for metrics that we did not yet implement. In the same line, I would also like proposals for layouts that we have not yet implemented. I'll show you the layouts that we do support. They are right here. you may choose any of these. So if I were to choose random and then hit layout again, I would just get smoosh. But if I then wanted a circle, I could lay that out again and get a slightly more comprehensible, though not entirely comprehensible graph. So it still remains the case that we have to invest a good deal of manipulation of the graph to make it comprehensible, but I believe that the tools for doing so are now under your mouse pointer rather than in a development environment requiring coding. With that, though, I think if there are questions, I'd love to take them, but I think that provides something of a broad overview of the Excel.NetMap project. If I have a chance, I'd just like to thank again all the members of the project. Certainly I'd like to thank Microsoft and Microsoft Research for their support. Now that I'm no longer part of Microsoft Research, I still have a great deal of affection for the institution, and the work there has been phenomenal. And I should say that I will continue to have a relationship with .NetMap and the other collaborators around the project, even in my new role as Chief Social Scientist for the Telligent Corporation. Telligent also has a lot of data about social media, and we'll be tying .NetMap to some of those data sets in the future.
So this is David again. I don't know if people have additional questions. Questions haven't come in since that rather large burst. Okay, here's a question. Are graphs available in vector format like EPS?
That's a good question. You can copy them to the clipboard, but they are actually in bitmaps. So I would say that that would be a feature request, and the answer is currently no. We do not have a vector output.
Okay, here's one from Jennifer Victor. As for graph measures to include, I propose measures of connectedness such as maximum flow or point connectivity. These could then be added as attributes and plotted in the graph.
That's a very good suggestion. Thank you, Jennifer. We'll note that there's, first of all, we have an extensibility model, so it may be possible for those who have coding skills to simply implement and build that into our existing framework if, for example, we don't get to your feature in a timely manner. But I'd love to receive that suggestion in the email, and I'd like to put it on our pending task list. Thank you.
Here's a question from Laura Morales, a very simple question. A problem with other visualization software is that there is no option to create a legend of the graph properties. Is there a simple way to create these? Sorry if already explained as I joined the meeting a little late.
No, that's a very good suggestion, and we've had that criticism, and I think we're going to have to prioritize that feature. We do not at the moment generate legends in an automated way. You would have to do that by hand, and that obviously is a significant burden, especially if you're generating multiple graphs. So I'll take that as a vote in favor of legends, and I'll take that back to our development team in our next meeting. Actually, we'll meet tomorrow, and I'd love to bring them that feedback.
Well, let me throw in a question or a suggestion of my own, by the way, Mark, which is to throw in some capacity to analyze a dynamic graph. That is, if you have multiple time points, and allowing analysis and visualization of network dynamics.
That's a really good suggestion, and it's one of the examples of you could do it with NetMap, it's just not obvious. The visibility column, as I mentioned, is a remarkably powerful feature of .NetMap. We have done some time series analysis in .NetMap, and the way that we've accomplished that is by adding a time slice column to each edge. So an edge now would have an additional attribute, and you can simply click in the spreadsheet, add a column, call it time slice, and then put an integer there. So you may have every edge per day in a network, as an example. What you would then do is, let's say an edge has a time slice indicator of 1. You would then use the visibility column, and you would say you would add one more cell to the spreadsheet, and that would be current time slice. And let's just say we put the number 2 in that cell. Current time slice equals 2. We would then create a visibility formula. If my time slice equals current time slice, then 1, comma, if not 0, and paren. As you increment current time slice, the graph will turn on and off all of the edges that are in that time slice. And so it is a somewhat more manual method, but I will note that it is something that we keep discovering, that things that we haven't directly implemented can be done using the spreadsheet underlying it because of the power of Excel. So I hope that addresses it. Now, I will note that the dynamic filtering feature itself will support the idea of clicking through time slices. So instead of having to go in and, let's say, increment 2 to 3, refreshing the graph, taking a picture, going in, changing 3 to 4, refreshing the graph, taking a picture, a very laborious process, we do have a work item where we would allow you to simply click the mouse and advance through the time slices. And quite possibly one advanced feature of that would be to simply animate the whole graph. Go ahead and generate a slice for every time slice present. Those are not yet features that are implemented, though, but as I mentioned, using the power of Excel, it's something you can do, it's just not directly supported.
Oh, interesting. I guess that again goes back to the documentation point, because there may be lots of functionality there which people may not realize if it's not documented. I mean, that is how one might make dynamic graph pictures. It's fairly straightforward the way you explained it, but if we don't have you there, it would be more difficult. Okay.
Now, in the interest of sort of the collective goods argument, we do have a wiki on CodePlex, and we are trying to document via the wiki. And questions of that sort are very welcome there on the wiki, and we'd love to hear from you. And hopefully the wiki itself will evolve into that documentation. And there will be a paper forthcoming, depending on who accepts it. We're hoping to target that at a publication like Connections, which is a journal of the International Network for Social Network Analysts that would document this tool.
That's terrific. Okay, suggestion for metric closeness. That is one of Freeman's centrality measures. That was a suggestion from PA Simon. Here's a question from B. Keegan. In addition to visualization, how tractable would it be to implement exponential random graph models, P-star or Sienna models, you know, the Snyders, Robbins, etc. stuff, to test the significance of a graph as a tool set?
That's a very good question. I'm going to defer to our developer on how easy that would be. I will know that the ergom models are very well developed in tools like Sienna and elsewhere, and it is possible that you could use the two together. At the moment, that hasn't been a very high priority work item, but I'd love to hear from the community whether or not we should increase its priority. But I take the point that evaluating the graph is a growing concern. Simply drawing the graph is not going to be sufficient in coming years, in part because the tools for just drawing the graph, as you can see, are getting so much simpler. So I take that point. Thank you.
Here's a question from James Danowski as a follow-up from, I guess, the question about dynamics. Would the traces of changes in positions be visible in dynamic graphing?
Oh, yes. Now, that's very challenging. The answer is no. You would essentially see a snapshot of each time slice, but we have developed one technique, and as you know, these are the kinds of things that we really need to get into the documentation. What we found was we would first do a visualization of the whole graph at all time periods. So we would take away the visibility constraint and simply say, show me every edge. We would then attempt to lay it out as best we could and then lock every node to their location. and then do the time slicing, at that point at least you get the stability in space of the node. So that would in some ways address seeing where the node was before. Perhaps it will appear and disappear, but it will always appear and disappear at the same location. If the questioner is referring to essentially, will I see a trail, will I see where it was beforehand, I see that as a very challenging problem, and I don't honestly have a good solution to that problem at the moment.
Okay, a question from Juliet Jarvis. Would it be possible to export the data to other software, for example to PIAC, to get other centrality measures?
Absolutely. I mean, simply file save as in comma-separated value. The data is in Excel. Excel is in many ways the neutral zone of all data. We read PIAC files, although we do a very crude job. We simply read the edge data. We don't do a very good job of reading the attribute data. I'd like to hear whether or not that's a very important feature from the community. But yes, once it's in Excel, getting it out of Excel is almost trivial.
Okay, that's good. Let's see, someone asked if I could repeat where the presentation will be available. It will be available at www.hks.harvard.edu/netgov, N-E-T-G-O-V. And so we'll put the PowerPoint and the recording of this up, and we'll also try to email everyone who participated. Let's see, Eric Gleave suggested that people who are participating submit the metrics they would like to see implemented. Could I suggest we will be posting, actually I had said we'd be sending you an open field question about feedback on this presentation. Let me suggest that you put in suggestions for metrics into that response. My guess is that producing metrics is probably one of the easiest things that could be added to NetMap as compared to, let's say, some of the stuff on network dynamics. Let's see, and then there's a statement from Jennifer Victor about making about the importance of attribute measures, but I think that was more just a commentary. Let me see. I'm just trying to see if there are any final questions. Hold a second. Actually, I just have to scroll down. The interface isn't so straightforward here. And let's see. I will. Again, I guess some of what I have said about the URLs and what we both said about the URLs has been lost, but we will just send an email to everyone who participated with the relevant URLs, both for the directly where to download NetMap as well as where the PowerPoints will be. So I think that's pretty much it. I want to thank you, Mark. This was a really, but both for the clarity of your presentation, as well as for your work on this tool. I think that it should get some wide use, especially because of its embedding within Excel, and I think it has actually some really nice functionality that isn't so easily available in some current network tools. So again, thank you very much, Mark, for presenting. And with that, I'm going to sign off. Thank you.
Can I get one last word in?
Please do.
Okay. So first of all, thank you all for the time. I think we've spent quite a bit of time, and I appreciate you taking the time from your day to listen. Second, I'm very eager to see .NetMap used in courses, classes. If you are considering the use of the tool in a class, I'd love to hear from you. And then just finally, I'd like to say thanks to Tony Capone and to Microsoft Research for their respective contributions to the project. Without them, it would not be possible.
Okay. Well, thank you again, Mark, and I'll bid everyone goodbye and thank you for coming.
Thank you all.